Good evening, everyone. Welcome to India's largest e-learning platform, Gradeup, and welcome to the session Rush and Crush Gate CS 2021. Join the session quickly. I'm waiting for you all to tell you what are the 20 most happening model questions in algorithms. Mithali, Anmol, good evening. Aditi Agarwal, good evening. Our machine world. Good evening. Hi Himadri. So guys, in this session I will be presenting 20 most happening model questions in algorithms. As I have already titled it as model questions, so don't expect the same question or same values or same statements to come in the exam. It's a model, so that kind of model in any way you may get. Okay, so before I start, let me introduce myself quickly. I am Satya, research scholar with 13 plus years of teaching experience and all the other credentials. So guys, without any delay, I will start. So first, from algorithms, if you ask anybody what is the very important model question, definitely what one will say, recurrence relations. Here there are two possibilities. One is which you can apply master theorem, other is which you cannot apply master theorem. So the first model question that happens frequently is recurrence relation, which you cannot apply master theorem. Like if I say something like T of n is equal to 4 into T of n plus 3 minus 3 into T of n divided by 2 plus 1. Suppose you are given to solve this recurrence relation. What we have to do? Definitely you have to follow substitution method. You have to follow substitution method. There is no other way. Right? So just I will give you how to approach. As this is just dynamically prepared question, I will be giving the questions. You can give every question answer in the comment box or in the Telegram channel. But I will suggest the approach. What is substitution method? When this is T of n, what would be T of n plus 3? That becomes 4 into T of T of n plus 3 will be 4 into T of n plus 3 plus 3 minus 3 into T of n divided by 2. What is n divided by 2? For n plus 3. N plus 3 divided by 2. Maybe this is very complex, but still I am trying to give you the model. This is plus 1 minus 3 into, when this is t of n, what would be t of n by 2? T of n by 2 plus 3 4 into t of n by 2 plus 3 minus 3 into t of n by 2 by 2 n by 2 square plus 1. So now you will elaborate n plus 6, t of n plus 3 by 2, n plus n by 2 plus 3, n by 2 square. Then in two more steps you will get an idea, so that you can generalize this, and finally it may lead to some big O of some time complexity. So this is the very first model question. So guys, you solve it and tell me what is the time complexity for this in the comment box. Now the second model question is, you may be given some code and you may be asked to find the time complexity of that code. Something like, suppose there is given a function void f of, let's say, int n. If n is less than 1, return else. Let's say you may be having something for I is equal to 1, I less than n, I plus plus, for j equal to 1, j less than n by 2, j plus plus, for k equal to n, k greater than 1, k equal to k divided by 2, printf percentile d, I plus j plus k, something like this. You may be given code and you may be asked to find the time complexity of this code. So what is the approach? Inner loop, from inner loop to outer loop we have to proceed. Inner loop, let's say it executes for x times, this executes for y times, this executes for z times. You say this would be big O of x into y into z. So what is that answer? You do it and comment, post your answers in the comment box. Okay. Next, third model question is, you may be asked direct question, that is, what is the time complexity of so and so? What is the time complexity of so and so sorting algorithm? Majorly, what sorting algorithms you have to focus on? Merge sort, quick sort, bubble sort, selection sort, insertion sort, heap sort. So you may be asked a question something like, what is the time complexity of merge sort in average case, or quick sort in worst case, or insertion sort in best case, bubble sort in best case. Generally, best case means generally bubble sort will come. So this is one possibility from sorting algorithm. Or in these sorting algorithms, we have the terminology internal sorting, external sorting. Internal sorting means which use the memory that is allocated. External sorting means which use the extra memory than allocated. We have only merge sort in these 6 as external, all the other are internal. And there is another classification, stable, unstable. Stable sorting algorithms, unstable sorting algorithms. Means if you have duplicate elements, if they change the order of appearance of the duplicate elements while sorting, they are said to be unstable. Remember, IBM are stable, SHQ are unstable. I for insertion sort, B for bubble sort, M for match sort are stable. S for selection, H for heap, Q for quick, they are unstable. Easy. Okay. Next, the fourth model question is from sorting algorithm again. It can be numerical this time. For example, if bubble sort is used, okay, just let me change. Suppose if insertion sort is used for elements, for sorting the elements, let's say 27, 32, 5, 40, 10, 16, 67, 50. Suppose these elements, the elements after third pass is dash with some 4 options. After third pass, what are the elements sequence? Or maybe with merge sort, maybe with bubble sort, maybe with selection sort, maybe with quick sort. Like this, a numerical question possibility is there from algorithms. So what is the approach? If you take these 27, 32, 5, 40, 10, 16, 67, 50, insertion sort will pick the smallest element and place in the first position by shifting all the other elements. This is pass 1. Pass 2. You will take the next smallest element and place in the second position by shifting all the elements. Like this, after third pass or after fifth pass, let me make it after fifth pass. What is the sequence of elements? Okay, this is one possibility. Next, the fifth most happening model question from algorithms is from hashing topic. We know hashing means you will be given the key, you have to map those keys to the hash table slots. This process of mapping keys to table slots we say hashing. Whenever you get collision, for collision resolution, you will be having techniques. One is hashing with chaining method. Other is, this is called open addressing. Other is closed hashing. Okay. Linear probing, quadratic probing, double hashing. Now, you may be getting a numerical question. Suppose if the table has 8 slots, hash function is so and so. Example, I am telling like h of k is equal to k modulus 8. Then elements to be placed are, let's say, 72, 61, 121, 37, 42, 57. Then 121 is mapped to what slot? Something like this. Or which has same slot, which has different slot. If you get collision by doing some linear probing, quadratic probing, double hashing, you will resolve the question, the collision. Some probing technique will be given. If you follow this probing technique, what are the slots that these keys got? This is the 5th model question. Then the next model question is from hashing itself, theory based. Theory based, like advantages, disadvantages, or you are having the hashing formula or hashing function for especially for quadratic probing and double hashing. From this, something like you may say which hashings or which technique does not suffer from primary clustering, or which does not suffer from secondary clustering, or which technique can allow any number of elements, can map any number of elements. Something like this, you may get a theory question, theory based. Next model is from graph traversals. You know there are 2 traversals, breadth first traversal, depth first traversal. Suppose I am giving you a graph A, B, C, D, E, F, G. Suppose this is the graph we have got. Take the start node as G. Tell me one possible BFS sequence or one possible DFS sequence. One possible BFS or DFS sequence. Post your answers in the comment box or in the Telegram channel. Okay. Next. The next model question that you can expect is from dynamic programming applications. Generally, you will be getting some match the following kind of question from applications on one side, design technique on another side. So this is the model question generally we get. So what are the applications of dynamic programming? You say Bellman Ford algorithm. You say Floyd-Warshall algorithm. You say matrix chain multiplication. You say 0-1 knapsack problem. Something like that. So you should, yeah, longest increasing subsequence, longest common subsequence, longest bitonic subsequence, subset sum problem. Yes, there are n number of applications, but my intention is you have to have an eye on these applications of dynamic programming also, because from those applications you may get a question. Next is Floyd-Warshall algorithm. From Floyd-Warshall algorithm you may get a numerical question. Suppose you are given a graph, some A, B, C, D, E. Something like this, you have got a graph and you know the Floyd-Warshall algorithm procedure. First we will have initial adjacency matrix. The question may be the adjacency matrix formed for node C would be dash. Something like this. Example I am telling, model question. So first you will take the default adjacency matrix. 5 nodes are there, okay. The default adjacency matrix, this is what the initial adjacency matrix: A to A0, B to B0, C to C0, D to D0, E to E0, A to B2, A to, yeah, again you may have these directed edges. Something like this. So A to B, A to C, I have let's say 3. A to D, I don't have any channel initially, so it is infinity. A to E, it is 4. Like this, first we will fill the initial adjacency matrix and then we keep on constructing B, A matrix, B matrix, C matrix, D matrix, E matrix. Finally, in the E matrix, you will get all pair shortest path. So, Floyd-Warshall algorithm you call as all pair shortest path problem, and the time complexity of it. The time complexity of it, that is big O of n cube. So from Floyd-Warshall algorithm, you may expect a time complexity related question or this numerical question. Okay. Next is next is From Bellman-Ford algorithm, you may get similarly the time complexity related question, that is again big O of n cube, of course. And Bellman-Ford algorithm is what? You can say enhanced version of this straw algorithm. Bellman-Ford algorithm is a single source shortest path problem, shortest path algorithm. This is the worst case time complexity, Bellman-Ford algorithm, Sudhir Kumar. Yeah. And you may get some numerical question also. Like you will be given a graph with negative weight edges. Something like this. So which is true, which is false from this? So what is the Bellman-Ford algorithm shortest cost for particular route or for particular source and destination? So you may be getting some numerical question. But with Bellman-Ford algorithm, it works with negative weighted edges. But if there is a negative weight edge cycle, Bellman-Ford algorithm may not work. But the beauty is it can detect that there is a negative edge cycle, negative weight edge cycle, right? Next is from minimum cost spanning tree. What are the ways? We have Prim's algorithm, we have Kruskal's algorithm. NKIT travel, negative weight edge it work, but if there is a negative weight edge cycle, then Bellman-Ford algorithm also fail. But Bellman-Ford algorithm can detect that there is a negative weight edge cycle and there is no solution for it. That is the beauty of Bellman-Ford algorithm. So for minimum cost spanning tree, we have Prim's algorithm and Kruskal's algorithm. From these you may get, like by given you are given a graph. Something like this. Let's say these are marked E1, E2, E3, E4, E5, E6, E7, E8, E9, E10, and you may be given like E1 cost is 7, E2 cost is 9. In this way, all the edges cost is given, and which edge may be used, which edge is never used. While constructing minimum cost spanning tree. This throw will not work on negative edge, but Bellman-Ford algorithm work. Yeah, again, it does not work means it may not. We can't say exactly, Sudhir. Yes. Okay. This is the next model, and then from the spanning tree itself you may get some theory based question. Theory based means for a given graph, something like for a given graph G, if number of the cost is doubled, like if the cost of each edge is doubled or tripled or something like this, then option 1, shortest route does not change. Let's say this is statement 1. Statement 2, spanning tree does not change. NKIT Travel Freak, Prim's algorithm says a starting vertex will be given, but okay, Prim's algorithm, generally the least cost edge connected vertex we will take as starting vertex. Only for Prim's algorithm, while beginning we will select this least cost edge connected vertex. Any vertex you can do. So like this, you may get a theory based question and you may be asked which statements, which of the above true. You can say only S1. You may say only S2. You may say both. You may say none. Possible. Similarly, the next model question is from master theorem it is possible. Like you may be given some recurrence relation, something like T of n is equal to 8 into T of n by 4 plus let's say n square, something like this, or T of n is equal to some 4T of n minus 2 plus n. Means basically master theorem generally we use on two cases. For decreasing functions, for dividing functions. Manisha, happy Bhogi. Sudhir, yeah. Yes, Sudhir, you are correct. So, master theorem based means from decreasing function or dividing function you may get a question. Guys, I am telling you these are all model questions. Just to give you idea. Next is greedy applications. From greedy application you may get, like what are different greedy applications? You say Huffman coding. You can say fractional knapsack. Then you can say optimal merge sequence. Prim's algorithm. Kruskal's algorithm. Like this, there may be n applications. So, as I said in the match the following, you are supposed to remember what are greedy applications also, from which you may get a question. Then travel freak, there is a possibility that the spanning tree may change. Sudhir, come on Sudhir, this is actually okay. Master theorem for decreasing function means, Sudhir, the format is T of n is equal to a into T of n minus b plus n power k. So we will just see a value when a greater than 1, when a equal to 1, when a less than 1. When a greater than 1, we are having one fixed time complexity. When a equal to 1, when a less than 1. Just we will use this and accordingly we will write the time complexity. Direct formula based. Nothing to explain there. Okay. Yeah, tomorrow there is no class, Manisha. So the next model is matrix chain multiplication. Like from this matrix chain multiplication whose time complexity is big O of n cube, again you may be given, let's say there are two matrices A1, A2, A3, A4, four matrices. A1 order is, let's say, 3 by 4, 4 by 2, 2 by 5, 5 by 3, something like this. Then the minimum number of multiplications. You may be asked, or you may be asked, which two matrices will be multiplied first? Or what is the optimal multiplication sequence? Or you may be asked for what k value you will be getting this so and so number of multiplications, the final k value. Okay. The next model question that may be possible is on optimal merge pattern. Optimal merge pattern, yes, you may be given multiple sets. Let's say you are given sets S1 with 7 elements, S2 with 9 elements, S3 with 15 elements, S4 with 3 elements, S5 with 6 elements, something like this. Then what is the optimal merge sequence? Or you can say what are the minimum number of comparisons? And the next model question is from Huffman coding there is possibility. We know Huffman coding procedure. We will write the distinct characters. We will write the frequency of the character. And we will follow optimal merge sequence. Then we will find out the number of bits for this encoding. So you may be getting a question, how many bits you can save? How many bits can be saved with Huffman coding? Than brute force method. Or we know Huffman coding is a variable length encoding technique. So variable length encoding number of bits minus fixed length encoding number of bits. Means with respect to fixed length encoding, how many bits you can save. Like this, from Huffman coding there is a possibility. And from Towers of Hanoi, you may get a question. From Towers of Hanoi also you may get a question. Like, first of all, the time complexity, the number of steps or number of disk movements, you say that is 2 power n minus 1. The time complexity. Or you may get here, let me add one more, like knapsack problem. From knapsack problem also you may get like you have 0, 1 knapsack, fractional knapsack. So you may be asked to find the profit gained. And the last but one model, I can say from this straw algorithm, you may get a question. Maybe maximum is theory based question. As we just discussed, what is the disadvantage of this straw algorithm? It may not work. This straw algorithm may not work on negative weight edge. That's why we have got Bellman-Ford algorithm actually. And you have to see the time complexity. What is this straw algorithm time complexity? You can say big O of n square. Of course, vertices into edges. Then you can say what this straw algorithm is based on what? Greedy method. So this straw algorithm related, you may get a question. So these are the 19 different model questions, and definitely we cannot predict accurately. So the 20th model can be definitely some new model question from the syllabus itself, because IIT is expert in framing new model questions. So definitely there can be a model which we don't expect, right? So guys, the intention behind this is, what are the subtopics or what are the areas you should focus on these algorithms. That's why I have figured there are just 20 most happening model questions. So now, don't you feel algorithms is very easy for you to prepare? Just simple. Like this, try to view anything as simple by really doing the simplification. It is not like false impression or false understanding. You really should know how to simplify the thing. Okay. MSQ type will not have negative marking, but there will be no partial award. There will be no partial award for MSQ question, and there is no negative marking. Negative marking is there only for MCQs. Yeah, Yadav. The point is, I always tell you, don't take intra-subject choice while preparing for GATE. Means within the subject, you don't take the choice like I should prepare this topic, I should leave that topic. That is wrong. Maybe in the worst case, you may take inter-subject choice. Inter-subject choice you may take. Okay. That means you may leave one subject in the worst case. That is also not recommended, but you may leave one subject. Got it? But within the subject, guys, never take any choice. I hope you understand this. All right. So guys, all India level, there is a free mock test in the All India level on 17th Jan, that is on Sunday. So you can attempt this live mock test. Live mock test this is. So that as it is happening all India at all India level, definitely you can feel that competition and you can get your rank also among thousands of aspirants. So at least you will have some idea, okay, this is our preparation level, so we have to push more. So don't miss this wonderful opportunity. Before gate exam, you are actually writing the gate level exam, isn't it? So guys, don't skip this. Register now for this gate 2021 all India mock test. Okay, that's all for today, guys. Tomorrow there is no class. Next class we will have on 15th Jan at 8:30 p.m. We will be discussing page tables. So difficult. Let's break the mind. So I will bring page tables questions and I will show you the easiest way how to solve page tables questions. Okay. Thank you so much for joining. Prep smart, score better, go Gradeup. Thank you guys.